Hello and welcome back to the lab. So today we're going to continue with the restoration of this 1946 Packard Pla-Mor Jukebox Amplifier. Last time we removed all the components from the top of the chassis, um, stripped and completely repainted the chassis in this bright fire engine red color, which was the original color, by the way. So we restored it back to its original color. Now the paint has had some time to cure and is ready to start reinstalling some of the components from on top of this chassis and underneath as well. Um, Today I wanted to concentrate on the high voltage power supply, the B plus power supply, if you will. So we're going to be putting in the power transformer. Um, we're going to put in a 3-wire power cord where a 2-wire power cord was originally for safety, right? Um, the fuse holder goes in here. 5U4 rectifier tube goes in over here. We have 2 filter capacitors that will go in here and here. Also, this amplifier originally did not have a power switch. Um, the power was supplied through another electromechanical mechanism elsewhere in the jukebox, not part of the amplifier itself. But because I'm not going to be using this as a jukebox amplifier, I'm going to have to add a power switch. So I acquired one from a donor parts unit of a completely different thing. I took the power toggle switch out of that, and we will install it somewhere in this area. I'll drill a hole through the chassis front panel and give this one a power switch so we can turn the power on and off. So let's get started with that now. First, let's take a quick look at the schematic of the power supply that we're going to be restoring today. It's your standard high voltage power supply with a tube rectifier. 120 volts comes in here. I didn't draw on the schematic the 3-wire power cord that we're going to install or the fuse or the fuse holder. I wanted to show you, this is the fuse that came out of the unit. There's supposed to be a 1.5 amp fuse inside this fuse holder, but when I opened it up and took a look inside of it, one of the previous owners of this amplifier had installed a 20 amp fuse. Look at the size of that thing. That's just craziness. I don't know why you would put a 20 amp fuse in this thing and expect it to catch on fire. I'm not really sure. But the breaker on the side of the house is a 15 amp breaker. So there's no way this fuse would ever blow. Uh, the main breaker in the house would trip before a 20 amp fuse would blow. I'm surprised this amplifier didn't burst into flames. So I'm going to replace this 20 amp fuse. In fact, I think I'm just going to toss this straight in the trash and replace it with a standard 1.5 amp fuse like it's supposed to go in the fuse holder. And then we'll reinstall the fuse holder in the chassis of the instrument, of the amplifier. Um, we're also not on this schematic is going to be the toggle switch that will be in the line here as well. And also the 3rd wire of the power cord will be grounded, connected to the chassis for safety. So here's the main power transformer. It has a 5-volt winding for the heater of the rectifier tube. It's a directly heated cathode. There's no separate cathode. The heater filament is the cathode in a 5U4 tube. So that tube will heat up very quickly because it's a directly heated cathode. Also, a high voltage winding off the transformer, very high voltage, 400 volts on each side of the center tap to ground, going to the plates of the rectifier tube. Output of the rectifier tube goes to 2 filter capacitors, 2 electrolytic can style capacitors in series. So each one of them is 20 microfarads rated at 450 volts. So altogether, when you put 2 capacitors like that in series, their capacitance is cut in half, but their voltage rating doubles. So this becomes effectively a 10 microfarad 900 volt capacitor. And that's really good because the high voltage over here at this point is probably somewhere in the neighborhood of 500 volts. And so we need more than one 450 volt capacitor in series. There's also connected across the two capacitors some bleeder resistors. These happen to be 240K 1 watt bleeder resistors. Now's a good time to talk about safety. Something like 500 volts DC here. That's a lethal voltage. If you accidentally touch that, you probably won't live to tell the tale. So please be careful. And if you don't know what you're doing around high voltage electricity like this, please refer all repair work to someone who does know what they're doing. Old timers that work on tube circuitry will tell you it's a good idea to always keep one hand in your pocket when working on high voltage circuitry. That way, even if you accidentally touch something, chances are pretty good it's not going to pass through your entire body and kill you. You might get burnt pretty badly, but it won't. It might not kill you. So that's a good practice to keep your hand in your pocket. But please, 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 um, lethal voltages can stay on these electrolytic capacitors even when the unit is turned off and unplugged. If the capacitors are good and they're not drained off thoroughly by these bleeder resistors, lethal voltages can stay on these capacitors for many, many months, even after the unit has been unplugged and turned off. So please, if you don't know what you're doing, refer servicing to someone who does know what they're doing. The original capacitors that were here are these two capacitors here. The negative side of these can style capacitors is connected to the can itself of the capacitor. So in this can capacitor, which is this lower one here, this lower 20 microfarad capacitor, the original one is this capacitor, and I'm replacing it with a new capacitor. But the positive terminal of the capacitor is the center terminal here, and the negative terminal of the capacitor is the can itself. Now for this lower capacitor, that negative terminal is connected directly to the chassis ground, as shown here in the schematic. So this can will be at 0 volts with respect to the chassis. But the same is not true for the upper capacitor. The upper capacitor is this one here, and you'll notice that it's got a cardboard insulator around the outside. That's because the negative terminal of this capacitor is still the can, but the negative terminal at this point is not connected to the chassis ground. It must be insulated from chassis ground. In fact, there's several hundred volts at this point. There are several hundred volts DC on the can itself of this capacitor when it's operating. And even when it's not operating, it can store that charge for a very long time. So the outside must be insulated. And also the negative terminal, which is the can of the capacitor, must not contact the chassis ground. It must not short out ground to ground. It must be insulated from ground. So instead of mounting the chassis, the can directly onto the chassis with these terminals, it actually must be mounted on an insulator. So we're replacing both of those capacitors with the two new capacitors, the hayseed handfest capacitors that I showed in the last episode. So this one with the can on the outside will be the lower capacitor mounting to the chassis ground. And this other capacitor with the insulation on the outside will be mounted in an insulated spacer, isolated from chassis ground. It will be this upper capacitor here. Let me show you on the chassis where they go. All right, so the lower capacitor that is connected to the chassis ground which would be this one with the uninsulated can on the outside. It goes in this space here, and you can see that it mounts into this metal piece that is directly riveted to the chassis itself. So this can will drop in here, and its outer shield will be connected electrically and mechanically to the chassis. This will be at 0 volts with respect to the chassis. The other one has to be mounted in this phenolic spacer. When I removed the old capacitor, I actually accidentally cracked this phenolic spacer, and I have to replace it. So I had to buy some replacements for that. So there's a replacement there, and I will drill the rivets out that hold this phenolic spacer in and replace it with a new one. And I'm going to use screws instead of rivets for the replacement. And the insulated capacitor will mount in that phenolic spacer insulator like so. And that way, even though this can is at several hundred volts above ground, there's no way you could accidentally touch the outside and get a shock or hurt yourself. And it also would be insulated to electrically prevent it from shorting out to ground. So let's drill out these rivets and replace this little phenolic insulator. So I drilled out the rivets and removed the cracked insulating spacer and replaced it with a new insulating spacer and replaced the rivets with screws. Tighten the screws, and now that insulator is good as new. And then when I had my drill out, I reinstalled the fuse holder. I enlarged the hole for the 3-wire power cord because the hole for a 2-wire power cord was much smaller. And I also drilled a hole for the power toggle switch that I'm going to install in this point here. I installed the 3-wire power cord and its strain relief, and I installed the toggle switch for the on-off power control. And then I realized that I'm going to be working on both sides of this chassis, some components underneath and other components sticking up from the top. And I'm going to need some sort of jig to hold this thing suspended above my workbench so that I can work on it and then be able to flip it around. So I ran out into my garage and took some scrap lumber and made this. It's pretty ugly, but it doesn't have to be pretty. It just has to work. This way, the tubes and the transformers and the capacitors can hang down from the top of the chassis underneath while I work on the underside of the chassis. And the chassis is screwed into the top here with a couple of removable, they're sheetrock screws, actually is what they are, drywall screws. And so I can remove it easily and work on both sides of the chassis with this little wooden thingy. So I'll be using this off and on throughout the rest of this restoration. Something else I wanted to show you, it looks like the ladies who did the wiring underneath the chassis on this amplifier originally signed their names. Here we see Opal, looks like BA25, Betty S, and Lee M. There's Betty S again. I guess she signed it twice. Thelma, Dessa ER12. So all those ladies, I guess, originally worked on this amplifier. I'm going to leave those names for sure. What a cool piece of history. Now with the amplifier chassis turned right side up, I installed the main power transformer and the 2 electrolytic can capacitors that I'm going to need for the high voltage circuit in this amp. I wanted to replace the original hardware with brand new stainless steel hardware, but I didn't seem to have the correct hardware that I needed. So I placed an order for all that, and when the stainless steel hardware comes in, I will swap these out. Flipping the unit back over, I did all the wiring underneath the chassis for the high voltage power supply, wiring in the new power switch, the fuse holder, the new 3-wire power cord. You can see the third wire, the green ground wire, is connected to a lug that goes directly to the chassis. I tied off the 9.5 volt AC winding that I'm not going to use, and these are the 6.3 volt heater winding. I'm temporarily not going to wire those up. I'm just going to leave them closed off with a little piece of heat shrink temporarily. Um, Here you see the filter capacitors with their bleeder resistors installed. Those bleeder resistors are metal film. I decided that I'm going to replace all the carbon composition resistors in this amplifier with modern metal film resistors. There's no reason to keep those old carbons in there. Probably most of them measure okay still, but even still, I'm just going to swap them out. Yeah. So again, high voltage here. So please be very careful. Don't stick your fingers where they don't belong. Um, Even when it's turned off, there may still be a charge on these capacitors. Turning the unit back over again one last time. Uh, Drop the rectifier tube in there. This is the original tube that came with the amplifier. I don't know if this tube is good or not. I do have replacement 5U4 tubes, but they don't have this cool Coke bottle glass shape. They're the more modern shape. So I'd prefer to use the original one if it's still good. I don't really know if it is or not. But with the tube installed, we should be good to go. So let's plug it in. Oh, let me flip it over again and hook up a voltmeter to the high voltage line and see what we can measure. Okay, moment of truth. Ready to put the fire to the wire? Hopefully no actual fire. This will be the first time this unit has seen power in who knows how many years, probably decades and decades. So anything could happen. But I am ready to shut the main power off if anything does. Here goes. No arcs and sparks. And we are measuring voltage. Goodness gracious. We are measuring 587 volts. 587 volts. That's a lot of voltage. There's no load on this except for those bleeder resistors. So that's why the voltage is higher than it would normally be. But even still, that's an awful lot of voltage. All right, 587 volts. That's what our B plus will be until there's a load on it anyway. Let me shut the power off and see how quickly those caps drain down. All right, we're down to around 100 volts. 60, 50, 40, 30, 20, 15, 10, 5, and about a volt. All right, that's good enough. All right, very good. So the high voltage power supply is working and fixed. All right, so that will do it for today's episode. Thank you very much for watching. Please like and subscribe, and stay tuned for the next installment of the restoration of the 1946 Packard Pla-Mor Jukebox Amplifier. Thanks for watching.